Lesson 1-3, Order of Operations, and in this lesson you'll learn to use order of operations to evaluate real number expressions. Let's take a look at the real world application for this. Investments. Bobby Jackson is investing money in stocks to help pay for her child's college education. She buys 1 share of Kind stocks at $16. She also purchases 5 shares of Tainer stocks for $35 each. The expression below represents the amount of money Miss Jackson spends for the stock purchase. Okay, so if you look at this expression right here, the cost of 1 share of Kind stock is $16. Okay, and add the number of Tainer stocks, which is 5. Okay, will be equal, multiplied by 35 will be the cost of 1 share of Tainer stock. Okay, so that is the expression that represents the amount of money Miss Jackson spends for the stock purchase. And numerical and algebraic expression often contain more than one operation, and this is what we call a numerical expression because they are just numbers. If there's a variable there, then this becomes an algebraic expression. Numerical and algebraic expression often contain one or more operation. A rule is needed to let you know which operation to perform first, and this rule is called the order of operations. Again, another review of the order of operations. To find the total amount of money Miss Jackson invests, evaluate the expression 6 plus 5 times 35. Which of the following methods is correct? Again, the word evaluate is being used, and when we say evaluate, 2 things come to mind: substitute and simplify. So let's evaluate. Let's take a look at method 1. So in method 1, what they did was you multiplied first 5 times 35 and you added 16 and becomes 191. In method 2, they added first 16 plus 5 is 21 multiplied by 35 gives you 735. If you notice, you get 2 different completely answers for these ones. Okay, one is 191, the other is 735. Okay, the answers are not the same because a different order of operation was used in each method. Since numerical expressions must have only one value, the following order of operations has been established. And this is what you need to write down. Okay, again, a review of order of operations. Simplify expressions being in grouping symbols such as parentheses, brackets, braces as indicated by fraction bars. Evaluate all powers. Do all multiplication divisions from left to right. And do all addition and subtraction from left to right. Okay, based on the context of the problem, the order of operations, obviously method 1 is correct. Therefore, Miss Jackson invested $191 in the stock market. Okay, and this comes to mind what we learned about, please excuse my dear Aunt Sally. Okay, and PEMDAS. As you recall, P represents parentheses or grouping symbols, E represents exponents, multiplication and division, MD, which has the same priority. If you see them on the same line, you go from left to right, and same thing with addition and subtraction. Once you finish with multiplication and division, there's addition and subtraction, you go from left to right. Let's take a look at example number 1 and see how this works in detail. We want to evaluate 5 times 7 minus 6 divided by 2 plus 3 times 2. We don't see any grouping symbol, so the next thing is exponents. So we need to evaluate 3 times 3 or 3 squared. This now becomes 5 times 7 minus 6 divided by 2 plus 9, because 3 squared is equal to 9. Okay, Now that's out of the way, we now have multiplication and division. So we multiply first. We multiply 5 times 7 first. It becomes 35 minus 6 divided by 2 plus 9. Then we go to division, which goes after multiplication. 35 minus 3, because 6 divided by 2 is 3, add 9. And since now you only have subtraction and addition, you always go from left to right. 35 minus 3 is 32, plus 9, and 32 plus 9 will give you 41. So the value of this expression is 41. Okay? In mathematics, grouping symbols such as parentheses, brackets, and braces are used to clarify or change the order of operations. They indicate that the expression within the grouping symbol is to be evaluated first. When more than one grouping symbol is used, start evaluating within the innermost grouping symbols. Okay, so let's look at example 2 and see how this works. Want to evaluate 8 times bracket 6 squared minus 3 times quantity 2 plus 5 close quantity close bracket divided by 8 plus 3. Okay, so copy the entire problem in your notebook. And then it says there, when more than one grouping symbol is used, start evaluating within the innermost grouping symbol first. So in this case, if you notice, the innermost grouping symbol is the parentheses, so we'll evaluate 2 plus 5 first. Okay, the value of 2 plus 5 is 7, so we end up with 8 times the quantity 6 squared minus 3 times 7 close bracket divided by 8 plus 3. Okay, and now that's done, we start evaluating what's inside the brackets. Okay, so now this becomes 8 times 6 squared, because we now have exponents before multiplication, so we evaluate exponents first. 8 times 36 minus 3 times 7 divided by 8 plus 3. And then we multiply 3 times 7 next, end up with 8 times bracket 36 minus 21 close bracket divided by 8 plus 3. And then we continue simplifying the bracket, which now becomes 36 minus 21 would become 15. 8 times 15 divided by 8 plus 3. That's and going from left to right, we multiply 8 times 15 before we divide by 8, and then add 3, and then we get 120 divided by 8. That becomes 15 plus 3, and finally end up with 18. So the value of this expression is 18. Okay? Next one. An algebraic expressions can be evaluated when the values of the variables are known. First, replace the variables by their values, then calculate the value of the numerical expression. Okay? So the figure at the right is a rectangle. Letter A, find the perimeter of the rectangle when S is equal to 5. And letter B, find the area of the rectangle. Again, when you talk about these types of problem, it is being assumed that you know the formula for perimeter. Okay? So, the perimeter of a rectangle is the sum of 2 times the measure of the width and 2 times the measure of the length, or perimeter, a little bit of review, okay, is equal to 2 times the length plus 2 times the width. We also created another formula for perimeter, if you recall, and that is perimeter equals 2 times the quantity L plus W. If you notice, I only used the distributive property from here to there, but we will review distributive property later on as well. Okay, so following the formula for perimeter, which is 2L plus W, okay, we know for a fact that width is represented by S in this case, and length is represented by S plus 3. Okay, so you now have 2 times S plus 2 times S plus 3. Okay, and substitute the value of 5, okay, when S is equal to 5. So you now have 2 times 5 plus 2 times 5 plus 3. And then using the order of operations, do grouping symbols first. That's why you added 5 plus 3, that will give you 8. Now you have multiplication, 2 times 5 plus 2 times 8. Do multiplication first before we start adding. We now have 10 plus 2 times 8. Because this comes first, we go from left to right, and then we do 2 times 8 now. 10 plus 16, you'll end up with 26. So the perimeter of this rectangle, when S is equal to 5, will be 26 millimeters. Okay? And letter B, find the area of the rectangle. Again, it is assumed that you know the formula of an area of a rectangle. Okay? It's below, not above, so it's right here. Perimeter. It should be next page. Evaluate. Well, I guess not. Okay, then we'll add it to the other page. Okay, so from here, let me pull this all up, and then we'll do letter B. Okay, letter B. Again, it is assumed that you know the formula for an area of a rectangle. An area of a rectangle is simply equal to length times width. Okay, so let's recall what we have. And in our problem, our width is equal to S, and our length is equal to S plus 3. Okay, so applying that formula, we now have area is equal to S plus 3 times S. Okay, and if we substitute the value of S, which is equal to 5, okay, we can now see that this becomes 5 plus 3 times 5. Using the order of operations, we add what's inside the parentheses first. Area equals 8 times 5, or area is equal to 40 square millimeters. Okay, and that is the area of our square. Example number 4. A fraction bar is another grouping symbol. It indicates the numerator and denominator should be treated as a single value. So remember this as well when you talk about a fraction bar. Fraction bar can also be another grouping symbol. It indicates that the numerator and denominator should be treated as a single value. What does that mean? So if you look at 2 times 3 divided by 1 over 2, 1 plus 2, this simply means that it's parentheses 2 times 3 divided by parentheses 1 plus 2, and the sum and the quotient will be 2. The simplest form would be 2 because this becomes 6. Okay, divided by, change that color, 30, and you end up with 2. Okay, let's take a look at example number 4 and see how this works. We want to evaluate x cubed plus y cubed all over x squared minus y squared when x equals 4.2 and y equals 1.8. Again, in evaluate, 2 things to keep in mind: substitute and then simplify. So first we need to substitute the values of x and y, and this is what we get. So we have 4.2 cubed plus 1.8 cubed all over 4.2 squared minus 1.8 squared. Okay, using the order of operations. Okay, before we do that, it's asking you to estimate first and see if what we're going to get is going to be right or not. Okay, so we estimate 4.2 to be 4, okay, and 1.8 to be 2, and using those values, end up with 64 plus 8 all over 16 minus 4, or approximately the value of this expression should be around 6. Okay? Since we are lazy, we use a scientific calculator to figure this out. So, punch in the parentheses button, 4.2, and then y to the x button, and then 3, the addition button, 1.8, y to the x button, 3, close parentheses. This one will indicate your fraction bar. The parentheses, basically in the calculator, ensure your grouping. Okay, if you don't put the parentheses, it will not follow the order of operations. And the same thing in the bottom, put parentheses. Okay, and the same thing. Parentheses on the other end, and then press on the equal sign, end up with 5.5. Is the answer reasonable? Obviously it is, because it's close to 6. And that is example number 4. And we've come to the end of the lesson, and on Google Forms, type of summary of what you've learned by responding to the objective of the lesson and type of question you might want to ask in class about this lesson. Thank you.